You're walking along one day, sending your tweets, sending your snaps, and all of a sudden, your service cuts out. Tragic. But this also affects hospitals and nuclear power plants. Luckily for you, we've assembled a crack team of clueless undergraduate engineers at the University of Illinois to help solve this problem.
In order to detect a solar flare, we first must understand what types of radiation a solar flare emits. And in order to understand this, we must know how a solar flare works. The truth is, we don't entirely know how this works, but we have a good hunch that it's due to the magnetic fields in the sun. These magnetic fields are constantly reconnecting, and when they reconnect, sometimes they leave a helix of magnetic loops that forces charged particles out of the sun and towards us. This is called a coronal mass ejection, or a solar flare. When this solar flare accelerates electrons, protons, and a little bit larger charged ions, it creates photons across all wavelengths, which we can detect with several different types of detectors.
Electromagnetic fluctuation from the sun during a solar flare can cause fluctuations in the power grid that may cause electronics to blow out. This includes coffee makers, water pumps, and especially transformers in the grid, which are incredibly expensive and hard to replace. To protect nuclear power plants from these fluctuations, step one would be to disconnect from the grid whenever a solar flare is predicted. Then we could use local backup generators to power coolant pumps to maintain a safe environment at the nuclear plant. After the storm passes, we could disconnect from the backup generators and reconnect to the grid and continue functioning as normal.
Oh my, can I help? So, we know that solar flares have many interesting outcomes. However, though, we see on how they're formed simply by magnetic recombination. First, you go and you have a bridge, then it turns into a pinch, and then an explosion in which, as we've said previously, many high-energy particles, however, especially X-rays, are emitted. And with these X-rays, we can go ahead and actually detect it through the background of the thermal noise emitted by the high temperature of the sun, burning at 3.89 times 10 to the 26 watts. That's how much energy the sun gives off every single second. So it's hard to go ahead and to actually pick things out. But by using proper filters, such as a high-pass filter, as shown here, we can actually go ahead and isolate out the X-rays.
So we got the Earth, we got the sun, and we got a detector. We got to get it to high Earth orbit. Now, to get into high Earth orbit, we're going to need to use a multi-stage rocket probably, because that's 26,000 miles above the Earth's surface. So this could be done either using someone like NASA or a private company, and these prices could range from any number depending on the company's standards. The standards for getting a satellite of this weight up would be a light lift vehicle, which carries about 2,000 kilograms up into the atmosphere. This is the cheapest one, which is usually around 40 to 50 million bucks.
The price of the detectors, the filters, the telescope, the satellite, and as well as the ground keep-up for this system would be anywhere around $900 million. If you were to implement this on an Earth-based system, it would only be $500,000, but as also explained, you'd lose a lot of accuracy if you were to do that. Some courses offered at U of I that deal with these sort of equations and sciences include NPRE 446, Astro 210 and 404, as well as Physics 325, 435, and 540. NPRE 446 will deal more so with the science of the detector and how we detect this sort of radiation, whereas the Astro and Physics courses will deal more so with why the sun acts in this way and the science between all of that.
Wow, that was really good.
Oh yeah, I love that one, guys.
Yeah, it was. I mean, I liked their voices sounded really nice. I liked the information in the video. It was really
Really
cool.
informative.
Yeah, it was really neat. I really liked the way they did that.
Thanks for watching.